topics we're going to see in pure mathematics is the matter of what? Trigonometric ratios and identity. I was talking about trigonometry, and the word trigonometry essentially means three-angle measurements. So the building block for trigonometry is the right angle triangle. The building block for trigonometry is what is called the right angle triangle. So, and when we mention trigonometry, two major ideas come to mind, or we can say three. We have the matter of what is called trigonometric ratios, which will give rise to what is called trigonometric identities. And also we have what is called your Pythagoras theorem. Some books will say Pythagoras theorem or Pythagoras rule. So these three ideas are essential to our understanding of trigonometric ratios, to understanding of trigonometry, trigonometric ratios, trigonometric identities, and Pythagoras theorem. Right, so we've talked about trigonometric ratios, trigonometric identities, and Pythagoras theorem. These two will help us furnish us with this one, or will furnish this particular one. But these are the three essential ideas we'll be talking about. We'll talk about trigonometric, we're talking about trigonometry. There's also other aspects that boils down to things like what you call cosine rule, sine rule, but we wouldn't go much into those ones now. We'll just focus on those ones that will help us in our further math experience. Now, the next important idea we must take note of when we have a right angle triangle is to identify what is called the opposites. The opposite, the adjacent, and essentially the hypotenuse. Opposite, adjacent, and hypotenuse, because these three ideas will help us build what is called our trigonometric ratios. We know from our basic understanding of arithmetic that a ratio is relating two sides or relating two quantities that are the same. So when we say trigonometric ratio, it means the measurement of an angle with respect to what? Two defined sides. So now I will call this angle X, for instance. If I call this angle X, the side this angle sees is called the opposite, and the side that this angle is sitting on is called the adjacent. To further confuse you further, let me flip this angle upside down and show you something that is happening. Now, in this iteration, I'll put the angle X here. What I've done is just to turn it. Where the angle is seen will be called the opposite. Where the angle is hanging on is called the adjacent. So it's important you get these ideas very clear in developing this concept. Here, the angle, the side, the angle sits on the adjacent. Here, the angle hangs on the adjacent. The opposite is always the angle. The opposite is always the side the angle is seen. The opposite is the side the angle is seen. Now, this is what we call the hypotenuse. The hypotenuse is where 90 degrees is seen. Whatever 90 degrees is seen is called the hypotenuse. All right, so by way of continuing my work, I'm going to clean this part of the board and try to expatiate on this idea. Now, let's assume I draw this and I change the direction this way, and I bring the angle X this way. This is where the angle will be seen, and this will now be called the opposite. So you see that in this direction now, the angle looks downwards, and where this 90 degrees is seen is called the hypotenuse. And this angle will be resting on this side. It's now called the adjacent. So it's important for you to understand what's happening here, because every other thing we're going to be doing will be depending on how well you've understood this concept. So by way of still trying to confuse you, let me now flip it this way. If this is the angle in question and this is 90 degrees, what 90 degrees sees is called the hypotenuse. What this angle is seeing is called the what? It's called the opposite. Okay, let's take a different, I want to see if I could take a different feel to it. Okay, it doesn't really matter. It's called the opposite. And what this angle is resting on, this side, is called the adjacent. So you see that these are the labelings we have for this diagram. And it's important you take note of them, because these are the things we're going to now use to develop what is called what? Trigonometric ratios. All right, so